All right, lesson 3. This is the last one in this little mini chapter, and it is titled Unique Triangles. So we are actually going to be able to label triangles a little further in depth. Now, this is a little tricky and challenging, so you are going to definitely need to take good notes and refer back to them. So the first thing we're going to do is we're going to talk about this line that says unique triangle, more than one triangle, and not possible, which means it's not possible to label it either unique or more than one. And you're probably thinking, well, I don't really understand what those things mean, so let's kind of define each of them. So in order to label a triangle, a unique triangle, you are going to have to find the sum, so add together the two small sides so whatever measurements are the smallest, and it has to be greater than the third side of the triangle. So you're going to be given 3 measurements. You find the smaller 2 measurements and you put them together, and if they are greater than the other measurement left over, you have a unique triangle. So we are going to now kind of skip down here, and I'm going to show you an example of that. So unique triangle, there are possibilities of 4 different ways to label that unique triangle. So these are your 4 options. Option number 1, side, 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 or SSS. Okay, when you are given a triangle that has a side, side, side quality, it is going to be a triangle that looks like a right triangle, and it's going to have letters on it to label the triangle corners or vertices. And then it's also going to give you some measurements. So again, in order for it to be a unique triangle, you're going to take the smallest 2 sides. So I see the smallest numbers are 4 plus 3. Those numbers equal 7, and they must be greater than the third side. So the third side is 5. Is 7 greater than 5? If it's unique, you label it side, side, side if you get this property. Now let's say that you added the numbers together and it was 5 and 5. Well, then no, the answer would not be that it's a unique triangle by side, side, side. You would not label it unique. You would say it is not a unique triangle. So we're going to skip around to where it says not possible or not a unique triangle. So this is what you would label the triangle if that case wasn't true when you added those numbers together. So it is not possible to have a unique triangle if the sum of the 2 small sides is less than or equal to the third side. So let's recap that one more time since we skipped around. In order for a triangle to have a unique property called side, 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 the sum of the 2 small sides must be greater than the other side left over. And if that is not true, then you say it is not possible. Moving on. We're going to keep going with these side measurements. So if side, side, side is not possible, it could be that the triangle is given to you. So it's going to, again, look like a right triangle. Draw that in. Put your letters on. Remember, this part will be given to you in the picture. Maybe they gave you a side measurement, a right angle measurement, and a side measurement. That means it's a side angle, side, unique triangle. So if for some reason you're not given 3 measurements on the triangle, you just look for this pattern. Is there a side located next to an angle located next to a side? Well, then we'd say it's a unique triangle with side, angle, side properties. Well, let's talk about the picture maybe having a third option. And we call this third option angle, angle, side. So again, another triangle with each vertex or point labeled ABC. And in one angle, there's an angle measure. And in the second spot, there's an angle measure. And then you are given a side measurement. So you can kind of see the pattern here. There's an angle next to an angle labeled by a side. So you would say it's a unique triangle because it's angle, angle, side. And then your last option would be angle, side, angle. Has the same triangle labels, ABC. This time you have a 60 in the angle side, you have a 1, and then you have a right angle. So you can see the order here. Angle, side of a triangle labeled with a measurement, angle, and that matches angle, side, angle. So you're probably thinking, wow, that's a lot of information. It is. So you have, let's recap this now all together. You have 4 properties of unique triangles: side, 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 angle, side, angle, angle, side, and angle, side, angle. How do you pick one of these 4? You use the unique properties in each of them. You either add the 2 sides because you are given 3 measurements, or in the other 3 options, you're really just looking for a pattern. Is the side listed, then the angle, then the side? Okay, well then it's an SAS triangle. If you see none of these, so if SAS or angle, angle, side or angle, side, angle are not on the triangle and the measurements don't equal the 2 small sides greater than the large side, then it's just not possible to have a unique triangle and you label it not possible. There is one special scenario, and we call that special scenario right here in the middle. It is called more than one triangle, meaning you're going to deal with only angles. We have already learned in our last lesson that all angles in a triangle must equal exactly 180 degrees. They cannot equal less and they cannot equal more. If not, they're not a triangle. So if you are given 3 angles, like you were in the last lesson, and you take that angle plus the second angle plus the third angle, and they equal 180 degrees, you use this label, more than one triangle. And if you notice, down below in those other examples, there was not a triangle with 3 angles given. So basically, if you see a triangle that has 3 angles, add them up. If they equal 180, you label it more than one triangle, and you don't even have to worry about, is it a unique triangle? Do I have to use one of these 4 options? But if you're not given 3 angles, you then have to go to, okay, it's unique, and which of these 4 labels am I going to give it? And if none of those work, you use the not possible answer, okay? All right, so we're going to go down to some more examples here. It says, decide if from the information given whether it is possible to construct a unique triangle. It is possible to construct more than one triangle. So remember, this is our angles one. Or it's not possible to construct a triangle with any of these properties. So in the very first answer or information given, we have a triangle, and we're going to need to draw that triangle. So we're going to draw the triangle first, and you can see it's using the letters A, B, and C. It has the side AB being 3 centimeters. It has the side BC being 3 centimeters, and it has AC, so the long side at the diagonal being 8 centimeters. I got all of that information from right here in this box, okay? So this looks like I'm given 3 sides. So my unique triangle properties tell me SSS, side, side measurement, side measurement. That means I have to add the 2 small sides together. So I'm going to take 3 plus 3, and that gives me 6. That has to be greater than the side left over, or the larger side, which is 8. 6 is not greater than 8. Therefore, this answer is it's just not possible to have a unique triangle. In fact, more than one triangle can't even be an answer here because by process of elimination, I'm not given any angle measures, okay? Going to example B, let's draw ourselves a picture here. Angle A is 30 degrees. Angle B is 45 degrees. Now check that out. Does it make sense that in a right triangle, I put the B in that space? Even though every other triangle has gone ABC, it doesn't. Therefore, that means that B probably goes on the other side of our triangle at 45 degrees. And then it also says, here's a clue, that AC, so A, if I'm highlighting A down to C, is 6 centimeters. So let's look at the pattern we're given. Not all angles, so it can't be more than one triangle. So I have to decide, is it a unique triangle by one of these 4 properties? So let's look. I have a 30-degree angle. I have a 6-degree side, or 6 measurement side, 6 centimeter side, and then nothing. But, oh wait, I have an angle. So angle, side, angle. Angle, side, angle. So this is a unique triangle because of angle, side, angle. And I forgot to mark this one up here. This one is side, side. Oh, no, I didn't. That's because that was not possible. Can't label it side, side, side. Getting ahead of myself. Okay, third example. You can automatically see that if you're going to go draw this triangle, you are given 3 angle degrees. So if you are given 3 angle degrees, this option is out because you are going to take those 3 angle degrees and you are simply going to add them together. This is the nice, easy one. And when you add those together, you get 180 degrees. And we know triangles need 180 degrees, so we know the answer is just more than one triangle because that is the only property that deals with all angles. All right, last one in these little practice examples, we draw our triangle in, and it's telling us that AB is 6 centimeters. Again, this information is coming right over here. It's telling us BC is 4 centimeters and that angle A is 40 degrees. Makes sense where everything is placed. I know I cannot have more than one triangle because there are not 3 angles given. So I have an angle, a side measurement, and a side measurement. Angle, side, side. Angle, side, side. Yep. There's no property with angle, side, side next to each other. So this is a not possible triangle. Angle, side, side doesn't exist in these 4 properties up here. So I just call that not possible triangle. All right, so you kind of have some variety of those examples. So what you're going to do in your practice is there are 5 problems and you are going to need to draw first, like I did in mine, and place all the measurements or angle measures or sides and measurements together before you consider, am I dealing with more than one triangle, all angles, or am I dealing with unique triangles and I need to pick one of these 4 properties, and if they don't exist, it's just a not possible triangle. Remember, if that triangle doesn't equal 180 degrees, it is also not possible. Okay, if you need to review these, you can always watch that video again, stop on some of my explanations to help you through that practice, and then on your